all it focuses on is we wanted to add tokens, and then the LAO guys were like, add loot, and so loot is like non-voting shares, and then the last thing is like being able to kick somebody, and like just those things introduced a couple pieces of complexity on their own because of how tokens can go wrong, and building out, you know, sort of, you know, specific structures to just handle those edge cases. So I'm gonna walk through this now.
That's great. Thanks.
All right, cool. I'll just get started. Import some things, safe math, ERC20 interface, reentrancy guard. So grab that. Just blanket eliminate reentrancies, because why not? There's a summoner address set at by the constructor. It's whoever deploys the contract. There's a clock. So there's periods, and so a period is a number of seconds. And so right now it's set to 4.8 hours in the current one that's active, which means there's 5 periods a day. And what this allows us to do is like have the other variables in terms of periods. And so I can say the voting period length is, you know, 35 periods, which means it is 7 days, right? And so this is how you determine the throughput. And so voting grace period, I'll get into that. Voting period is like, you know, you can vote on a thing, and then grace period's like the votes are final, but you can leave if you want. And so that protects you from other people, you know, using your money on stuff you don't want.
I have a question. Why did you pick having these periods as the quantum instead of having seconds as the quantum?
It's just a little easier to reason about because I only need to pick this number once, and then like I can, you know, just use like 7 or like, I don't know. I guess there's not a great reason. In theory, you could have done it the other way and just like use seconds for everything. But for me, it was like a little easier to do the math for these. Like if you're running a test or something, you're like fast forward, you know, 20 periods, right? Whereas otherwise I'd be like fast forward, like, you know, this many seconds. It's kind of weird.
Okay.
So, okay. Let me keep going. So emergency processing wait. So some of these variables aren't going to make sense until we actually like build up some of the other structures. So I'm going to skip a bunch of this. Emergency processing, I'll come back to. Bailout wait, come back to. Proposal deposit is just like when you submit a proposal, whoever the member is that submits it needs to put down a little bit of money. They get it back when the proposal is processed. It's an anti-spam mechanism. Dilution bound, I will come back to. Processing reward, this is just like a small amount of ETH to give to whoever processes the proposal. It comes out of the proposal deposit. And so, yeah. So like right now it's 0.1 ETH. So every time you submit a transaction, it's like $10 to whoever calls the process function. So there's never been a proposal that could have been processed that hasn't, because some people are running bots somewhere on the planet. Summoning time is just the start time of the DAO, and so that's used to figure out what period we're in. Deposit token is set at constructor, and so this is just like the token that is used for deposits, can never change once you deploy. If this gets broken, things go real bad. So, and this is sort of known, and it's because like we expect the deposit token to be like a secure, like won't have transfer errors or restrictions or anything type of token. So then there's the guild bank. So I'm going to open up guild bank over here. It's actually a little bit easier to reason about if you've seen the guild bank first, because the guild bank's super simple. So the guild bank actually gets made in the constructor here. Skip ahead a bit, but guild bank gets made in the constructor. This is the guild bank. It's got this only owner. Constructor just sets the owner. The owner is the Moloch contract, and so the Moloch contract is the only one that can call, withdraw, or withdraw token. So withdraw is for when somebody rage quits. Withdraw gets called. So withdraw gets like the address of a receiver. So like where does the money should be going? The number of shares to burn, and the total shares at the time of the burning. And this gets passed as like loot and shares. We'll show you that later. And then the array of tokens that should be sent. And so by default, when you rage quit, you get your proportional share of all of the tokens held by the guild bank. And so what it does is it loops over it and it figures out the fair share. So it does some math. So this fair share function, we were using safe math here, but then I didn't want it to throw. And so we do our own little check. And the idea is that one of the attack vectors could be that we inflate the balance of a token so large with the supply, if it's mintable, that now it can't be withdrawn, because when you multiply it by the number of shares, that's too big and you get a overflow, and I don't like overflows. So we just like do the math here first, and then return the right number based on that. So we get the amount, which is basically just like how many shares you have out of the total. And then it loops and figures out how much for each token, and then it withdraws that one in a loop, right? Withdraw token, this gets called when the DAO makes a payment. And so if the DAO is going to, something I added is that's different from Moloch v1 is in Moloch v1 you could only mint new shares, and that's how you paid people. In this one you can request like, I want 100 DAI, or I want 100 ether. And so when that happens, then it comes into this, and then it does the withdraw token function, which just says, for this one token, just send the amount to the person, right? Pretty simple. One thing I glossed over is this approved tokens here. Sometimes by default, it's all the tokens in the guild bank, but there's another function in Moloch DAO called safe withdraw, or safe rage quit. And what that does is it allows you to specify the tokens to withdraw in case one of them is broken and you get out, but I'll come back to that. So any questions about the guild bank so far?
What is the point of having all the calculations in the guild bank? Like, it doesn't store all these variables, you just pass it. So why don't just do the fair share calculation in the Moloch contract?
No good reason in terms of that. What I will say is I like the idea of having the guild bank be separate, because then it makes it easy to tell, like on Etherscan, how much money is in it. Because I can look at the Etherscan on Moloch and be like, oh, here's the money in escrow for active proposals. People have offered tribute, whatever. And the guild bank, I can see like, here's how much assets are actually stored. As for where the fair share calculation is done, you're probably right. Could be either place.
Just one more thing about this approved tokens.
Actually, the thing is, you have to do it every time. You have to do it for every token when you're looping over it. So unless you pre-calculated that and then pass the values for each token, yeah, you might not. So I don't know. Maybe that's a good reason. There's another question.
Yeah, I want to ask about the approved tokens. So when we were talking about the Moloch DAO, there was like only one token that can be specified, or there can be more tokens?
So
I was confused there.
For version 1, it was just one token, and you could offer that token for request shares or get shares, which you could then rage quit and get that one token, right? So we're sitting with one token balance where you're just slicing it up in different ways with shares. In this one, it can have a portfolio of tokens. And so I'm going to get into that.
I'm going to say that it's not a question, but I actually like the separation of concerns of having all the financial related math on GuildBank. For some reason, I don't have a very good reason, but I actually like it.
Yeah, it's just like a conceptual boundary, you know. You're just like, okay, all the GuildBank stuff, it's in the GuildBank. I can look at, like, that's the most important. That's like what determines, like, you know, tokens, where they live, how they get moved. So it's like, if you can build confidence on that first, then it's like the rest of it may be easier. So that's what we're going for. Here are a bunch of constants. I'm not going to get too much into this. Long story short, they prevent overflows. So this is just like hard-coded limits, because, like, fuck it. And the events, but the events are doesn't matter. We'll fix those later. So proposal count is important. Proposal count is different than proposal queue. So in version 1, there was just a queue. Only members could submit a proposal, and the proposal would go directly into the queue. Version 2, anybody can submit a proposal, but what submitting a proposal does has changed. When I submit a proposal, it just goes into the contract storage. Anybody can do it. It just sits there. It doesn't go into the queue. It doesn't go in line to be voted on, to be in the grace period, to be processed, etc. A member has to call a different function called sponsor proposal to move a submitted proposal from just sitting around in storage to the queue. And while it's sitting around in storage, it gets an ID, and the ID is proposal count, starts at 0, counts up. That's it. Total shares and total loot just track the total number of shares and loot across all members in the DAO. Emergency warning. I'm going to come back to this. There's conditions that allow you to that put the DAO in sort of an emergency state. If, like, processing a proposal gets stuck, I'll come back to that. So voting. Voting is if you don't vote, it's null. It's just doesn't count. You know, it's a 0 value. If yes, you know, you can, but if you vote, you have to vote yes or no. You can't, like, vote and abstain, because it's the same thing. So members track their delegate key. So as a member, you have your addresses split up. It's a pretty common pattern at this point. I want to hold the money on my member account, so that's the only one that can rage quit. And then I have a delegate account, and that's the only one that can sponsor proposals and vote on stuff. I have to use this delegate key to vote. If I and at any time the member address can update the delegate key. By default, it's the same thing. So shares, how many votes you have, loot, how much non-voting shares you have. They have a one-to-one relationship in terms of, like, money. So if you have 2 shares or 2 loot, you'll get the same amount from the guild bank if you rage quit. Exists is just like a nice little thing that's, you know, has this member ever been created? So you don't have to track, like, have they set a delegate key to 0 or something, right? Highest index yes vote. This is important because, so this is the proposal index based on the queue that is at the highest index that the member has voted. And so there's this other thing in the DAO where we had to build a bunch of constraints around continuous entry and exit. So if you want to have continuous exit via rage quit, there's a sort of unfortunate condition which could arise, which is like, I vote yes on a bunch of stuff and then I quit and take all my money and leave. And now if those votes pass, whoever is stuck, you know, left in the DAO has to pay for all of that, right? And so I don't want you to be able to vote yes on things and then leave. So if you vote yes on something, you have to wait until it's processed, even if it fails, before you can leave. So the greatest security risk in terms of a delegate key is, like, if I have my money and Giancarlo is, you know, my friend, I'll be like, vote for me, man. And then he'll be like, okay. And then he'll vote on a bunch of stuff. And I'll be like, hey, I'm going to quit. And he'll be like, just kidding. You know, I voted on all this stuff. You can't quit yet. And I'll be like, God damn it. So that's, you know, the risk around delegates. They can't take your money, but they can make you stuck for a little bit. That's sort of fine. Jailed is this new thing. I'll come back to this. But long story short, it has to do with the token transfer restrictions breaking down. I'm trying to build up the like not edge cases first and then come back to all the edge cases. So I'm going to keep doing that. Is the pace okay for you guys? Too fast, too slow? Cool.
Fine.
All good.
So applicants, proposals have all the details, right? Who's the applicant? So this also changed slightly from version 1. In version 1, you had an applicant and I think it was called a sponsor then. Not exactly sure, maybe it was a submitter or something. Long story short, the applicant is, if it's a proposal for money, that's the person who gets the money. If it's a proposal for guild kicking, that's the person who's getting kicked. I overloaded it just for those 2 use cases, but yeah. And further, like the applicant has to put down their own money, so the applicant has to be the one to call submit proposal. If there's any money that's coming, it comes from them. I'll get into that in a second. So proposer is, oh wait, yeah, okay. So I mixed this up slightly, just reading my own notes here. So applicant is the person who wishes to become a member, but like all the money comes from them, and then the account that submitted the proposal is the proposer. Can be a non-member. Maybe I need to look at this a little bit more detail, but we'll come back to this. Sponsor is the member that sponsors the proposal. Shares requested, how many shares do you want? How much loot do you want? Tribute offered, how many tokens are you offering as tribute? And then the tribute token type, so like what kinds of tokens are you offering as tribute? And then if you're requesting payment, how much you're requesting and in what token. These can be the same, but like it's sort of really silly if they ever are. I didn't explicitly prevent it, but it's like, I'll give you 100 DAI for 100 DAI, you know? Doesn't make a whole lot of sense. But what it does mean is that like I can offer OTC trades to the DAO. I can be like, I see you've got a lot of ETH there. How about you give me some of those ETH and I give you short ETH tokens. And then, you know, the DAO can decide whether or not to do that. Starting period, this is only set once it has been sponsored. And so this is based on the index, so like it gets computed when it gets sponsored, and based on your position in the queue, it figures out what the starting position should be. If there's a bunch of stuff in the queue, then it's like, okay, I will like put you at the end of the queue and you start after the thing that's at the last. But if there's no queue, then it's like you start next period. The number of yes votes and no votes it's received, and the flags, which I just had to cram these because Solidity sucks. So I put them all in an array. This is the minimum I could do with getting the function, variable, stack, whatever. You know what I'm talking about.
Yeah, the stack depth.
Details is just like extra data. So like we've got links to, you know, Dropbox paper, like IPFS or whatever, that just explains what the proposal is about. Could be anything. Max total shares and loot at yes vote. I'll come back to this one too. And then votes by member. So each proposal stores who's voted on it by their address and what they voted. And this prevents you from like changing your vote or voting twice. All right, cool. So there's a token whitelist and approved tokens. There's a proposal type to get onto the whitelist. We also keep track of sort of like intermediary things. So like I don't want 2 token whitelist proposals to be going on at the same time. It's sort of nonsense. So it's like if there's one active, you can't do another one. In order to do that, I had to track which things have been proposed to the whitelist. These get set when you sponsor. Same for guild kicking. It doesn't make sense if there's 2 guild kick proposals for the same member. Then we track the the members as that, and then we also track the delegate key, so it's a reverse lookup. So if I have the delegate key, I can get the member address. Then we just have this time, this is a mapping, but of integers. So this is the proposal count that I talked about before. So when it starts at 0, counts up. And this is just the ID of the proposal. And then you have the proposal queue. And so, something to keep in mind is you've got proposal ID and then proposal index. Proposal index is its spot in the proposal queue. It only gets set for proposals that have been sponsored. Proposal ID is just for all proposals that have been submitted, even if they have not been sponsored. Okay, modifiers. Only member. So only member, it's like you have to have at least some shares or loot. And this is what's used for like calling rage quit, right? If you don't have any shares or loot, you can't rage quit. If you don't have any shares or loot, you can't call update delegate key. Why would you need to update your delegate key? You can't do anything, right? Only shareholder. So only shareholder, this is specific because you want to make sure that somebody's a shareholder. Where do I use this? Only shareholder. Oh, right. So yeah, you can rage quit if you have loot and not shares, but you can't update your delegate key if you have no shares because you can't vote. Only delegate, and this is what's used for voting and sponsoring, and that's it. So, and that just does a member lookup. So it's like, does the member address that you're representing have any shares? And so you can understand why this is like sort of annoying to have done with like multi-delegates. Because like then it's like, oh, I have a delegate, and then it votes, and it's like, but I looked up the member, they have all these shares, and it's like, how many of those shares got used in that vote? It's like, it's a huge hassle. And then people can assign delegates to each other. No good. All right, so any questions on before the functions? Cool. All right, moving on. Constructor does all the obvious things, uses the style of, I think I picked this up from the Raiden contracts like years ago, but we just like underscore all the variables that just get set to the global. Pretty straightforward. So summoner, you can preload it with approved tokens, so you don't have to go whitelist a bunch of stuff right off the bat. Period duration, the timing, voting period length, grace period length, emergency processing wait, bailout wait, both of them will come to. Proposal deposit, dilution bound will come to, and processing reward. Okay, bunch of checks to make sure that things are what they appear, what they should be. So the summoner cannot be 0. So you pick the summoner. It's not whoever deploys the contract. Makes testing easier, right? Like, so you can provide an address. Period duration has to be greater than 0, or else nothing's ever going to happen. Voting period length has to be greater than 0. Voting period length has to be less than the max voting length, which is the 10 to the 18. Same with grace period. And then you've got come back to emergency and bailouts, dilution, yeah, you need at least one approved token when you deploy, because that approved token gets set as the deposit token. So the first token in the array of approved tokens that you provide is the one that gets set as a deposit token. So like that's going to be like WETH probably, or DAI for most of these. Okay. Yeah. Like,
does the proposal deposit have a default up there?
No.
No. Okay. So wasn't it like 10 ETH? Oh, those were comments, were they? Okay, those were all comments. Okay, cool.
Yeah. So I put them into the code just so like it helps people when you have something concrete to wrap it around, as opposed to being like, here's a value. You have no idea what it's going to be.
Yeah. Cool.
Okay, so then you go through the approved tokens array. You make sure it's not 0. You make sure it's not already whitelisted. It's only going to be whitelisted if you've just added it. So then you add it to the whitelist, and then you push it to the approved tokens array. So if something if there's a duplicate token, it'll pop out here. Deploy the guild bank. set all the globals, set the summoning time, create the first member. And so this is, this is just like the easiest way to do setup, which is like you pick someone. And that person just does all the work of getting the first other members into the DAO. And like they have complete unilateral control as the one and only shareholder with one share that gets made. And so they get a free share. So this is me and Moloch DAO, and I've submitted the proposals and then voted yes on all of the other members until they got in, and then people started submitting stuff themselves. So this sets all of the total shares, member address, delegate key, stuff you need to set up a member. Emit, summon, complete. We can add a bunch of events here if we want, but all right, cool. So now we have a DAO. Now what happens? Well, the first thing that's going to happen is we're going to submit a proposal. Breadth first for a second. There's 3 different types of proposals. So I can submit a proposal, I can submit a whitelist proposal, or I can submit a guild kick proposal. These all call into the common internal submit proposal. So they all do basically the same thing, but here we check for slightly different things, and we pre-fill fields that are not necessary. So like for guild bank, we don't need, or for guild kick, we don't need a payment amount or loot requested or any of that type of stuff. So, all right, back up to the top. So here we make sure that we're less than the total number of shares in loot. This isn't maybe not super accurate, because like I should add the total shares that exist and the total loot that exists and stuff. I can't remember why we changed it to not do that, but maybe you guys can think about that. Token whitelist. Oh yeah, so anything offered as tribute has to be already whitelisted. Anything requested as payment also has to be whitelisted. Applicant can't be 0. The member, if the applicant is a member, they can't be in jail. We'll come back to that again. Collect tribute from the applicants and store it in Moloch until the proposal is processed. So when you submit a proposal, if you have tribute as part of that, it gets stored on Moloch.sol contract, not the guild bank. And so you can see what's in escrow is in Moloch.sol. That's the stuff that has been offered but not yet processed. Funny story, there is about 100 WETH that is forever going to be in the current Moloch v1 contract, because at ETH Denver last year, I watched somebody, instead of doing what I said and approving WETH to the contract, they just sent it. And I was like kind of stoned. I look at his computer, I'm like not moving too slow, and then it dawns on me, I'm like, dude, you just lost 10 grand. He's like, what? He goes through like all the 4 stages of, grief, denial, bargaining, like before my eyes in like 30 seconds. It's kind of funny. And this is the best part. Like I try to speed up his transaction to stop it, right? I try to just send WETH somewhere else, right? I'm acting quickly. And this is when I discovered that MetaMask's speed up transaction only shows up after a 30-second wait. And I'm like, hey, Dan, do you ever think that somebody who desperately needs their transaction sped up might not want to wait 30 seconds? And that was a contribution that I made to
Wow.
So moving on, bool flags. I guess this just makes the flags array. Doesn't set any of the flags. Because the flags are to indicate whether it's a guild kick proposal, it's a whitelist proposal, whatever. And going back to the flags, going up here.
I have a question about the flags.
Yeah.
I see it's an array of bools. Did you think of creating a structure, and why did you choose an array of bools?
Great question. Because I needed to get rid of a bunch of variables quickly. I don't know if a struct might have done that. That would have been ideal. I don't like using the array of bools. I'm not a big fan of it because like you have to think, okay, is this 4? Is this 3? Is this 2? What the fuck is going on, right? Hopefully you guys will memorize this.
I already have a note. Okay. Thanks.
But yeah. All right, going back. Yeah, so bulls, blah, blah, blah. Okay, and then so then we pass this off. Applicant, shares requested, loot requested, tribute offered, tribute token, payment requested, payment token, details flags, all the data, right? Difference between this and like the other 2 proposals is like, I don't need to check about, you know, certain other things like, I'm not checking like the number of shares requested and loot requested. I'm not checking the applicant address here, stuff like that. So what I am checking is like, you know, you're trying to whitelist a token, you provide the address, and it can't be one we've already whitelisted. And then here we set flags 4 to true, and flags 4 is where is it in the proposal? Right. So I'll just copy this comment to make everybody's lives easier. Sponsored process did pass canceled whitelist. So 0, 1, 2, 3, 4. It's a whitelist proposal. If it's 5, it's a guild kick. Right. So maybe you won't have this on your commit, but whatever for the thing for the talk. So this returns, I'm getting stuck. This returns proposal count -1. It doesn't really need to. This is just so like if we wanted to call this from a contract, we could then, you know, do something useful with the ID if needed. I don't know if anything is going to use it, but it's there. So whitelist proposal does the same thing, but like the applicant is address 0, shares requested 0, loot requested 0, attribute is 0. Just the token to whitelist is the tribute token, so that's overloaded. Mindful, and then the amount is 0. Payment requested, all the stuff 0, right? Guild kick, similar story. You look up the member, make sure that they have at least some shares or loot, or why are you trying to kick them? Can't kick the summoner. That's an interesting thing, and the reason is because the summoner has a special role to play in bailouts, which I will get to. And the member must not already be jailed. So now we're getting into it. A successful guild kick results in you being jailed. The reason that you get jailed is because you might have voted yes on something that has not been processed. If I tried to give you all your money back, I create an incentive for people who know that they're about to be guild kicked to go vote yes on everything, to try and get it to pass, and then get kicked out and not have to deal with any of the consequences. That's not great. So what we make you do is we put you in jail, you deal with all the consequences of anything you voted yes on. Once you voted yes, once the final thing you voted yes on is done, somebody calls another function which is called rage kick. And so I'll get to that soon. Okay, so now looking at the actual submit proposal, really all it does is it puts all the data into the struct and it saves it by the proposal count and in the mapping, right? So it's a mapping by the ID is the proposal count. Then why do I get the member address here? Member address by delegate key. All right, I guess I'm just broadcasting this. Right, so as you can see, the applicant is the applicant here. And the proposer is the message.sender. So whoever called submit proposal is the one who is the actual proposer. But I think I skipped this line. When you submit the proposal, it does the token transfer. So from the message.sender. So this is actually slightly off because the proposer is the one who is putting up the money, not the applicant. The comment is wrong. So I'm going to make that the proposer. The proposal and the applicant can be the same person, doesn't matter. That's fine. The reason that we did it this way is because in Moloch v1, the most important vulnerability that Nomic Labs pointed out is that approving the contract is unsafe. So if I called approve for the maximum limit amount that people normally do, or even if I called approve for just like 100 WETH that I was about to offer as tribute, somebody else who's watching that, they have to be a member obviously, but somebody else who's watching that could then come in, submit a proposal that takes all of my tribute, puts me as the applicant, and then gives me no shares. And because a member has to submit the proposal, I can't do anything about this, right? So I added two things in V1. One was an abort. So if I have one day, if I like see that my proposal's not set up properly, I can abort it as the applicant. But I took that out in this case because we fixed it in this way. And so the fix is that now, because when you submit the proposal, the money has to come from whoever's submitting it, which like if it's some applicant offering tribute, you can just like say either give me the money and I'll do it, or like do it yourself. Like the account that approves knows that nobody else can ever pull their money into Moloch without their consent. They have to be the one to call the function that pulls their money into Moloch DAO, which means that approvals are safe. Now I can approve, you know, a whole bunch, like 2 to the 256 minus 1 or whatever, and then I'm not worried that Moloch will ever pull in my money and surprise me. So that's why it's done like that. Okay. So then, yeah, you save all this stuff, increment the proposal count, and that's submitting a proposal. Any questions on just that part?
Okay.
Anything? All right. So then there's sponsor proposal. So I'm a member. I see, you know, somebody's just Shayan's trying to join my DAO here, right? So I'm like, should I sponsor it? I don't know. All right, I'll do it. All right. So I pick it up by the ID. So I know which proposal I'm trying to sponsor. Put the ID in, and then it'll pull in the deposit from me. In this amount. So I have to approve the proposal deposit beforehand. And because this also comes from me, this also means that like whatever the deposit token is, I can approve a lot of. So if the deposit token is one thing and the tribute token is the same thing, then I can still be safe in approving a lot because nobody can ever pull the money in for me. Okay, so then pull up the proposal. Make sure it has been proposed, so it has a proposer, so that gets set from 0 address, so it has to exist. It can't have already been sponsored, it can't have already been canceled. So canceling is another thing. I'll come to that in a minute. Canceling is before a proposal gets sponsored. So the state machine for cancellation is like submit, sponsor, or cancel, right? I'm just, super high level. So you also cannot submit proposals or sponsor proposals for people that have been in or are in jail. Once you get jailed, it's permanent. That member address can never get more shares, never get more loot, anything. I thought that was like a simpler state machine than like, oh, you were bad, you got kicked out and jailed, but now you're good again. Now you can get more shares. This is just like, cut them off, right? If you want to join again, do it from a different address. Don't complicate my code. So sponsor proposal handles all of the proposals, so it handles whitelist or guild kick. If it's a whitelist proposal, then we check that we have not already whitelisted the token, and we check that it has not already been proposed to the whitelist. So the guild kick proposal checks that they have not already been proposed to kick. The reason we don't check like the equivalent of cannot have already whitelisted is because we sort of do it here where they must not be in jail. Because if they have been successfully kicked out, then they will be jailed. And so this works for both guild kick and normal. Like you can't receive, you can't be an applicant for payments or shares or loot, and you can't also be an applicant of a guild kick proposal because you're already in jail. So that's why it took it out there and moved it up. Okay, so starting period, like I said before, look at the proposal queue, look at the last thing in the proposal queue, take its starting period. If that starting period is passed, if that was period 9 and now we're in period 10, then like you start at 11. If that hasn't passed, if the starting period of the final thing in the proposal queue is like 11 and I'm in 10, then the next one's going to be 12, right? So set the starting period equal to that. I guess I could have saved a line here. Member address, look it up, set the sponsor equal to the member address. Probably could have saved a line there too. Flag 0 is sponsored, so that is true. And then you push it into the queue. So it only gets into the queue once it's been sponsored. All right. So now Cheyenne he's in the running in the style here. He's trying to offer some tribute. He's trying to get in, but now I'm going to vote on him, right? So the difference between voting and sponsoring is you sponsor by ID, but you vote by the index, and then you provide what you're going to vote, and you have to use your delegate key. Look up the member, get the storage reference, so we can make some changes. We make sure that the proposal exists by checking the index against the queue length. Get the proposal data. Your vote must be less than 3. This might be redundant with this line down here, where your vote has to be vote yes or no, but I think not. This is from the first version. I wrote this a year ago. I think I did this so that like the typecast wouldn't fail or something. Like if it's less than 3, it's like 0, 1, or 2, and then like it'll, this part will work, something like that. Okay, and so then you have to make sure that the voting period has started. So it calls this get current period. Let me just go to that real quick. So this takes the, how much time has passed. So I take now, say it's 1,000, something times 500. So that means 500 seconds have passed. If a period is, 100 seconds, then 5 periods have passed. Therefore, I'm in period 5. So you make sure the voting period started. Make sure the voting period is not expired. This does a similar thing. Then you do the votes by member. So you make sure that the current vote has to be null, right? Like you can't have already voted on this thing, and that's just the default value. And then your vote that you're about to save has to be either yes or no. Then you set it. If your vote is yes, add your shares to the yes votes, and then we do 2 other things. One is member specific, and one is global. So highest index, latest yes vote. And so this is like, if for the member, this is a higher index than something else they voted on. If this is proposal 10 and I previously voted on proposal 8, then I need to remember that I've now voted on proposal 10, because if I try to rage quit before proposal 10 is processed, I can't. I'm stuck, right? If I've already voted on proposal 12 and I vote on proposal 10, it doesn't care. It only cares about the last one. Okay. So this is another thing. So this is the maximum total shares encountered at ES vote. And so this is total shares and loot. And this has to be greater, or if this is greater than the total shares and loot at any yes vote on this proposal, then we store that. Okay, so what does this look like? the DAO starts, this proposal starts voting. There's 100 shares, right? I vote on it. I vote yes. It's 100 shares at the time I vote. 50 people rage quit. Somebody else votes yes, doesn't care because 50 is less than 100, so it doesn't get recorded. If while this thing is still in voting, 200 more people join, now we're at 250, somebody votes yes at that point, it's going to take that number. It's going to say, at the time of any yes vote on this, the highest number of loot and shares that existed in the contract was 250. This is what is used to compute the dilution bound. I'll explain it right now. The rest of this is a process proposal. So here's another weird edge case about continuous withdrawals, continuous exit. So let's say I vote yes on like great proposal number 3, right? And then right before it is like horrible proposal number 2. And there's 100 shares in the DAO. And the proposal was to like mint, 1 more share. And let's say I started with 1 share. So I have 1, DAO has 100, proposal wants 1. Let's say 99 of the other shares rage quit because none of them voted yes on great proposal number 2. I am now the singular shareholder in this DAO, and I went from being on the hook for this, like great proposal number 3. I have to stay in great proposal number 3, even though everybody else rage quit because of like unrelated, horrible proposal number 2. I'm still stuck here until proposal 3 gets processed. Now, horrible proposal number 2 is the one that mints 1 share. And so like now what happened is what I expected when I voted yes was that this is going to cost me 1% of my money because I'm 1/100th of the money. Now what happens is it's unbounded. I am now on the hook for basically half my money, right? Because I meant 2, there's 2 from 1. So I'm on the hook for 50 times more money than I thought I was going to be. That's not great. So the way we solve this is with the dilution bound. And so it says the maximum amount that the DAO will dilute for any specific person who voted yes on the proposal is like 3x. And I picked a number. And so that's what the dilution bound is up here. That's what gets set. So the default is 3. So let me fast forward to where we were. So what that means is that like in practice, if there's 100 shares, if 2/3, if you set the number to 3, then what it means is if 2/3 of the shareholders rage quit, if somebody had voted yes on a proposal and that number was 100, if by the time it gets to being processed, there are now 33, that's more, that's 2/3. And so it'll just automatically fail. That's safe. I like making things fail as a sort of philosophy here. False positives are much more expensive and risky than false negatives. False positives being a proposal passed that shouldn't have. A false negative being a proposal failed that maybe it should have passed. Because proposals passing can spend money. Proposals failing does not spend money. So if a proposal fails, everybody can just try it again, right? Like worst case, I'm still in, the 33 shares that are left can be like, we still want to do this. Let's submit it again, right? We acknowledge that we now need to pay slightly more because all the other people quit.
What's the threshold for passing?
Oh, right. No quorum, majority rules. If it's a tie, no wins.
Ah, okay. Because I was thinking in that case, what if like all the rage quitters like joined again before proposal number 3 was actually processed in. Okay, but if you're left alone in there with him and the proposal 3 would not pass either if no one else joins.
Right.
Okay.
So like, yeah. And so it serves to protect you, right? And so if it's like, it can be, the reason that we had to pick the highest number is like partly because of how because I can't there's no other function that's getting called to track this, the total number of shares in loop for a specific proposal, like along the way. So you can either pick like at the beginning when it's sponsored, or at the end when it gets processed, like you have the number, and like, or you could add a function to like record some, the total halfway through when it's done voting. And I was just like, fuck it, let's like do it the safest way that I could think of. And the safest way protects you against the case of like, I vote yes at, like it's 100 and then it goes up to like 250 and then it goes all the way back down. It's like, if the only person voted at like 100 and then it goes to like 50, then it's fine. If it goes to 250 first and then somebody voted yes at 250, then it reflects like that person's expectation of how much money that they were going to spend. And then if it goes to 50, like it protects them, because that's like a 5x multiplier, and the maximum is 3. I see somebody making faces. I'm going to keep going just because like there's a little bit more to this. And yeah, so get a glass of water real quick so you can stand up if you need a break for a second.
I'm gonna have a smoke.
Okay, so all that happens if you vote yes. The highest index yes vote, blah, 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 the dilution bound stuff. If you vote no, it just adds your shares, easy. And that's it. So then a bunch of people vote on Sharyon's membership proposal, and then it comes time to process it. So anybody can call, there's no modifiers here, except non-reentrant. So anybody can call process proposal. It takes the proposal index, not the ID, calls this validate proposal for processing function. Let's look at what that does real quick. So this is commonly called, so also there's separate functions for process guild kick, process whitelist, because they have certain things that are different. You don't want to run through all the code paths every time. First you check the proposal exists, you grab the data, make sure that the current period is greater than or equal to the starting period, the voting period, and the grace period all added together, which means it's ready to be processed. If I have a grace period of 5 and a voting period of 5, and my starting period is 1, well, then if I'm in a period 11, then I'm good. Flags 1 has to be false, can't have already processed it. And here's an interesting thing, is that the previous proposal has to be processed. So one of the other constraints that you get from continuous exits is that the proposals have to be processed in order, because what you don't want is like somebody to forget to process a proposal and then like, I voted yes on proposal 10, or I voted yes on proposal 11, and like somehow because they don't need to be processed in order, I can rage quit before that one gets processed, right? So you have to make sure they're done in order. All right, going back up. This is where a lot of the meat of the logic is. So we look up the ID by the queue. So in version 1, the queue actually held all the data, like it was an array of proposals, but in this one it's just an array of the uint, and it's pointer to it's the proposal ID, and so you can look it up from that. Yeah, the proposal queue. See, it's an array of uints, so it's really just the ID. All right, cool. So then must be a standard proposal. For you to call process proposal, it cannot be a guild kick or a whitelist. So that's what this checks. Set process to true. And then we do some stuff in did pass. And so this is where we determine if it actually passed or not. And we get this emergency processing thing back. So let's look at did pass real quick. There we go. So did pass given an index, returns whether it passed and whether we are in emergency processing. So the simple thing is to just say, well, are there more yes votes than no votes, right? If so, it passed, except if we're in emergency processing. So the first thing we do is check emergency processing. So here we're checking if get current period is greater than or equal to the proposal starting period plus the voting period plus the grace period plus the emergency processing wait. So let's say, for example, I set the emergency processing wait to 1 week. What this means is that if a proposal has not been processed for 1 week after it should have been able to process, something is very wrong. This is not good because there's only a few reasons why that could have happened. The most important and likely is that there was a token transfer that was part of this that failed. And so if you look in the other process proposal sections, there's a couple token transfers. So the first is that if the proposal passes, then I need to send payment to the applicant, and then I need to send the tribute to the guild bank. If the proposal fails, all I do, there's no payment, so I just send the tribute back to the applicant. Now, in both of those cases, there could be some sort of token transfer restriction, right? USDC could be approved by the guild, whitelisted, added to the approved tokens, and then somebody submits it as tribute, and their proposal could pass, and then Coinbase hates me, I don't know, sanctions, whatever, seems more likely these days. But they say, fuck your guild bank. You can't transfer USDC to your guild bank anymore. And we're like, okay, fuck. This is gonna break the whole DAO. So in the passing case, the token transfer would be going to the guild bank, and that would fail. But it could also be in the failing case where the applicant themselves is blacklisted by USDC, and so then sending the money back to the applicant fails. And because of what you guys just saw, which is all the proposals have to be processed in order, there's this, what it means is that if you can't process a proposal, then all of the other money that might be sitting in escrow as tribute is stuck forever. And so we added this emergency processing. So if it's been a week, then what do? We set emergency warning to true. And so this is just a global that starts as false and is set to true if there's ever been a emergency processing event. It sets the last emergency proposal index. So it's like, when was the last time we went into emergency processing? What was the index of that proposal? So the current proposal index. It sets emergency processing to true, and it automatically fails the proposal. So when we know that when you automatically fail the proposal, the only token transfer that should be happening besides, of course, the proposal deposit, which is why the proposal deposit is so important to not be a shit token, is the returning of the tribute. And so what happens, I'm just gonna skip to that part real quick, is like, if we're not in emergency processing, we send you your tribute back. If somehow your tribute, can't be transferred back to you, you just don't get it. Yikes. But that's sort of necessary in order for this to work at all. So let me get to the rest of the guild did pass, because there's a couple other things that'll make it fail. This isn't the fun one. And so this is actually the one we added the most recently. And so it's like one of the core aspects of this DAO is that I should be able to rage quit ahead of any proposal I don't like, right? But let's say I voted yes on the proposal that was emergency processed, right? After the proposal is processed, all of the other proposals that have been sitting there for 6 days or so after it can be processed immediately. So somebody could just, right, process them all. But if, let's say I wanted to rage quit one of those proposals, I now wouldn't be able to. Just in terms of timing, right? Somebody's going to call this function on a loop and be like, is there a thing? So I'm like, fuck, how do I get my money out ahead of this? I'm stuck, the fucking emergency. So what we do is just err on the side of safety. If you have a proposal that is in the grace period, when a proposal ahead of it is emergency processed, all of those automatically fail. And that's why we store the index of the last emergency processing proposal. So when you do the next one, it says, look up the last one, do some math, figure out if I was in the grace period when that one was processed. And if so, or then just, it's not if I was in the grace period, it's actually if I was past the grace period. If the proposal can be processed immediately after the emergency, then it should fail. That's the expected behavior. Like stuff that's in the grace period, then like I can still rage quit later. So I don't need to make all the stuff in the grace period fail. So this node is a little bit wrong. It was past the grace period during the last emergency processing. Yeah. So we'll have to make sure that's working as intended. It'll also fail if the did pass, or I'm sorry, if the dilution bound gets exceeded. So this is what I was saying before. So total shares add total loot multiplied by dilution bound. So if let's say this is like 100, right? Like right now it's at 100, then I multiply by 3 and I say, is 3, is this less less than the maximum? Because if the maximum was 300, then I should fail. Yeah, so and then also if the applicant is jailed. So if you have a proposal that should give you money, but then you get put in jail, that proposal fails. The jail, it's like a guild kick ahead of, like somebody submits the scenario for this is like somebody submits a guild kick for you, and then you're like, well, fuck it, I'm just going to try and give myself a bunch of money in this DAO, and if the guild kick passes, then it doesn't matter, if the second proposal passed, because you can't get the money anyway. If you're the applicant, so it just fails. Okay, so then it returns did pass in emergency processing. Now we're back here. It does a couple other checks. This is just like the hard code, overflow protection check. So it just says, if the total shares and total loot and total shares requested and total loot requested are greater than the maximum number, then just fail. Don't issue more shares and loot above the maximum. I guess this is why I don't need it in the submit, because it's here. So make the proposal fail if it is requesting more tokens as payment than available guild balance. This is sort of obvious, like I request 1,000 DAI. I don't need to check that the guild bank is good for it up front, because maybe somebody else is submitting tribute ahead of me. But like when I get to the processing, if the guild bank doesn't have 1,000 DAI, then like I can't send it, so it's just gonna fail. This makes sure that like we're not an emergency processing. The payment token isn't 0, which means it's not like a other type of proposal. And like then we have the balance that they want. Okay. This is not just the proposal payment token. This isn't like only if there's guild kick or whitelist, because like it could be the case that I have a proposal that just doesn't request any payment tokens, and in that case that would be 0. All right, so if the proposal passed, then I have I set did pass to true on the proposal data, and then if the applicant is already a member, so if exists is true, then I just add to their shares and add to their loot. That's easy. If they're a new member, then I create a record for them. Part of this is setting the delegate key. So this is all this does is if somebody has set their delegate key to the address that I am now getting as a member, it takes their delegate key, sets it back to themselves, and then it sets my delegate key to myself. So that way, like, there's an attack without this code where like I could block somebody from being a member by like changing my delegate key to the address they want to join with, right? It's sort of silly. So that's what this does. It overrides the member, it sets them to themselves. And then, you know, whether or not your delegate key is taken, it does what, for you, it sets your address as the delegate key when it creates the member data. So it takes proposal applicant, member, and so the delegate key is this field here, and so that just also gets set to the applicant. Okay, and does the reverse lookup stuff. Okay, so then it mints the new shares and loot, just to keep track, total shares, add, proposal shares requested, total loot, same thing. Then it does the transfer of the tribute token. So this, we're still in the proposal pass part. So if it passed, I send the guild bank the money. And if I'm requesting a payment, then I withdraw token. And so this is where I call guild bank withdraw token. This is for specific one-off single currency payments. This is not for like rage quitting your proportional balance. If the proposal fails, then we return the money, and that's all we do. And so, yeah, we call, we only return it if if we're not in emergency processing. I suppose that it's possible that there could be a passing proposal that trips the emergency processing and then doesn't return the money. That's maybe not ideal, because if, let's say, I you know, had offered some tribute to join as a member and the proposal passed, but then like there was some other complication getting the tokens to the guild bank, maybe it's not my fault. So, all right. And then there's return deposit, and return deposit does very little. It just sends you, first it sends the whoever called process the message.sender the processing reward, and then it sends you the remainder of the deposit after the processing reward. So whitelist and guild kick are very similar. Any questions on process proposal before we go on?
One thing, so the loots were the shares that can't vote, right? But you use them if the member has a share that can vote. They can vote with the loots too. Like something I got confused there.
No, loots are just economic only. So it's like I vote with my shares. So like loot is there for a couple reasons. One is like maybe you want somebody to join and have a stake, but you don't want them to have voting power. Or let's say, you know, some massive giga whale wants to join. I want to give them like some voting power, but I don't want them to just take over all the voting power. And so I might split up their shares into shares and loot so that they still have, you know, can put in a lot of money and like have the same economic interest, you know, in terms of adding their shares and loot, but they can only vote with their shares. All right, 440 lines in, about 2/3 of the way done. It gets easier from here. So process whitelist proposal, do the same validation, look it up, must be a whitelist proposal. Yes, it's processed. Did it pass? We don't care about emergency processing here. If it passed, great, set it to pass, you know, add the thing to the whitelist, and then remove it from the like pending array of things proposed to the whitelist or the mapping. Return the deposit. Guild kick, same thing, except here we do the jailed thing. So we put the member in jail. When we put the member in jail, we remember what index of the proposal put them in jail. And I'll come back to this and explain why. If you had to guess, it has to do with token transfer restrictions. There's a lot like that. So here, what we also do for a member that gets jailed, gets kicked on their way to getting kicked, is we transfer all their shares to loot. So we say add to the shares to loot. Total shares is now minus your shares, and then total loot is add to your shares, and the shares is 0, right? So this prevents you from voting on anything, from doing anything, and because like that can't be changed ever, like that's it. Moving on, we went over did pass, went over validate proposal, went over return deposit. All right, so now rage quit. Rage quit calls _ rage quit, which just internal. It provides this message.sender. Reason why is because rage quit's sort of multi-purpose. So the difference between these two calls is like this one, I just take all the global approved tokens array and I pass that to rage quit. And in safe rage quit, I provide the token list of tokens to iterate over. And then I check those, make sure it's whitelisted. And this also makes sure that like tokens are unique and in ascending order. And then it just like passes that on. And the idea is like if a token breaks for some reason in the guild bank, everybody else should still be able to pull out all of the rest of their tokens. It's pretty straightforward. All right, so what does a rage quit actually do? It says, what is the initial total shares and loot? Add that up, get the member, make sure that you have the shares and loot that you're trying to burn. And so you specify when you rage quit how many shares you want to burn and how much loot you want to burn. So yep, and it could be in any combination. It could be like partial, it could be complete. It doesn't really matter. So then we burn it. So we say your shares is now minus whatever you're burning. Your loot's now minus whatever you're burning. Totals minus whatever you're burning. Same with total loot. Then you instruct the guild bank to transfer the fair share of the tokens to the rage quitter. So this is where we call the guild bank.withdraw, not the singular withdraw token, but the withdraw that goes and loops over all of this stuff. And so we provide the initial shares and loot, and then we provide the shares and loot to burn, which we got from adding them up, and the list of tokens to use. And so the list of tokens is either going to be what's provided in safe rage quit or all of them. Cool. Rage kick. So members in jail. Now what? One of two things is happening. Either the member has voted yes on something, in which case like if you go down here, this like can rage quit function, this can rage quit function gets called in rage quit here too, right? And it looks up your highest index yes vote. So let me go down to can rage quit real quick, right? So it says, first of all, the thing, I don't even know if this is strictly necessary, given that, I'm not sure, like this require might not be hittable. I don't know if I tested it, because how else would, I guess this is like, because this is a public function. So yeah, you have to pass it the index of a proposal that exists. And then it'll return to you whether or not that has been processed. And so this will make sure that, rage kick, rage quit, all of these will make sure that you have processed your highest index yes vote proposal before you get out. So you sit in jail. So in rage kick, you're sitting in jail. You can't not be in jail. That doesn't work. You have to have some loot. So if I rage kick you, it's going to remove all your loot. So, this protects against calling this twice, because you'll still be in jail. Can rage quit we just talked about, and then must not be able to bail out. I'm getting close to explaining what the bailout nonsense is. So when I rage kick a member, it still calls the same rage quit function, And so I guess maybe this can rage quit is redundant because it gets called there too. But yeah, but here's the thing. Here's the interesting thing. I call this rage quit, I pass it the total loot for the member. So you're gone after this, right? You have no more interest, economic or voting in the DAO. But I also pass it the complete global list of approved tokens. And this is a trust issue. Because imagine I am now in jail. You guys have voted to kick me out. I'm now in jail. But let's say I don't want to call rage quit. I don't want to call safe rage quit. I don't want to leave. And let's say on purpose, I go get myself blacklisted from USDC, right? Now you can't kick me. The reason you can't kick me is because you have to provide the entire array of approved tokens. And so when you call rage quit with the entire array of approved tokens, then it's going to loop over all of them. And I can't trust you. So rage kick is something that's called against you, right? So I'm not going to allow you to pass in a custom array of tokens here because I don't trust you to give me all my tokens, right? If I'm getting rage kicked, and so the default has to be that you get all of it back, right? We're trying to be nice. We're trying not to take people's money, right? And so we're trying to kick you out, but give you whatever you have. It's like, take your shit, go home, right? And so there needs to be something else that allows after enough time where you could have been rage kicked, but you have not been rage kicked because when I tried to rage kick you, the token transfer to you failed and you're stuck there in jail, but unable to be kicked. Something else has to happen, and that is the bailout. So
but wait. Why not just like de-whitelisting USDC, rage kicking the person, then whitelisting USDC again?
Because it could be that USDC is only broken for them. Like I might not want to close in the whole DAO.
But de-whitelisting USDC wouldn't affect anyone else, and it would just be momentary. I mean, it's a coordination hell, but
right. So here's the thing about that. It's like one, there's no delisting.
Oh fuck. Yeah.
So that's one part of it, and two, it's like it's coordination hell because like any proposal in the meantime, right? I'd have to. So, let's say I had a delisting thing. It's like a, voting period, grace period for delisting, and then voting period, grace period for relisting. And like in my model of what's happening is like, there's sort of two failure modes. One is bad, one's really fucking bad. The bad one is like, a singular person is targeted by blacklisting, or like certain members, in which case like the DAO should still operate fine, but like those people might not be able to withdraw that money. They have to safe rage quit, but like other members could submit proposals to like give themselves the rest of the money and like, deal with it. The other is that like everybody, some token just fucking breaks, right? Like all transfers are halted on a token in the guild bank or in currently being offered as tribute. If it's just in the guild bank, everybody can like safe rage quit and pull all the tokens besides from that one. There's nothing really that can be done. But if it's in the tribute, that's why you need the emergency processing, because like the transfers are going to fail. So you just need to acknowledge it's stuck there and move on, right? Now, if it happens that a token is approved and like has been whitelisted and then breaks, I expect the DAO to just everybody quit. Like that's I think more likely, because what can happen is if you know that the token has transfer restrictions, anybody can like submit a proposal to like offer that as payment or something and like try to pass that, or like offer it as tribute and like try to do that, and then like push the DAO into emergency processing every time. and having members have the ability to put the DAO in emergency processing at will is not good. And so it should be avoided. Yeah. So, you know, this is like best I came up with. It was like, be very careful about whitelisting tokens with transfer restrictions. If you get one, we have a couple fail safes. If it's for a single person, that can only really be most bad if like we need to kick that person out and it prevents us from doing so. If we need to kick a person out and the token transfer restriction is failing to let us do so, then we have this bailout function. And so there's a bailout wait, and the bailout wait is like longer. So I was going to do a bailout wait of 2 weeks. Slight other edge case is like, it could have been the case that you were in emergency processing when you did the bailout. So like the bailout wait has to be longer than the emergency processing. Not going to go into too much depth about that right now. But just explaining the bailout, right? So you have to be in jail. You still have the loot, right? The same two requires is up here. And then now it's just can bailout. So let's look at the can bailout function. And so this starts the bailout wait starting period from one of two proposals, because either when you were kicked, when you were jailed, like when you were jailed, you either had voted yes on something and were then stuck there, or had not. And so if you voted yes on something, then it takes the starting, you know, it starts the wait from the starting period of the proposal that you voted yes on. And if you didn't vote yes on anything, then it starts the wait from when you were put in jail. What this means in English is like, I get jailed on proposal 10. I've not voted on anything. All people need to do is wait 2 weeks. If I don't quit in 2 weeks, then they can bail me out. However, if I voted yes on some later proposal, then the 2 weeks starts when that proposal gets processed. So what I'm doing here is I'm adding the bailout wait starting period, which is the starting period of that proposal, plus the voting period, plus the grace period, plus the bailout wait. Right, and so the reason that this has to be longer than the emergency processing is because what if the thing I voted yes on goes into emergency processing? I don't want to be bailed out before the emergency processing takes place, right? And yeah, and like maybe this needs to have a thing that's added to it, which is like, not just that the current period is greater than that, but like that proposal has been processed or something. If I vote, but I mean, at that point, every proposal like should have been processed. I don't know exactly. Maybe there's like a little bit of math I need to do to figure that out. But
I'm gonna be honest. Even like, I'll make it my mission to remove the bailout processing.
all right, man. Do it. I'd love that.
Yeah. I'll have to think about it. But
think about it. This is the best thing I came up with because of like the sort of, you know.
Yeah, I know. And I'm just saying that like of all the things that we've heard here today, I think this is what's scaring me the most, to be honest.
Good. It scares me the most too. So yeah, I would prefer not to have it. So, you know, if there's another way, open to suggestions, happy to implement, happy to test. So just, you know, what the bailout function does is it gives your loot to the summoner, and it sets your loot to 0. That's all it does. So like, you know, when it's working as intended, it's a nice thing, because like it's assuming that, you know, a single person is targeted by some sort of blacklist, right? Like they can't withdraw the money. I can't kick them because I can't help them withdraw the money. But if I give all their loot to the summoner can withdraw that and give it to them. right? And this could also be helpful if like you lost a key or something, you know. Cancel proposal, super simple. It's just, you know, just gives you your money back that you've submitted. So like when you submit a proposal, you can cancel it before it gets sponsored. So make sure it hasn't been sponsored, hasn't already been canceled. Make sure that you are the person who proposed it, and then it gives the proposer back the money. So this is all, the code is right. When I was calling it the applicant earlier, that was slightly off. Update delegate key, and this just updates your delegate key, make sure it's not 0. Skips the check if the member is setting the delegate key to their address. So if you're setting it to like your own, it skips a check. So this is like only shareholders. So you can only use your member address to do this. And so this only performs these 2 checks if your new delegate key is not the message.sender. And so then it'll check that it's not some other member's address and it's not some other member's delegate address. And then it saves it, updates it, sets your old member address by delegate key lookup to 0, updates your new one, sets the delegate key. That's it. Then there's some getters, but it's not too important. And that's the whole thing. So feel free to ask any questions. I can go back, start sharing if you have a specific code you want me to look at, or we could just end the recording here.
Yeah, one thing I want to say was like leave some code review for us too. But there was mainly like, so one of the things I read was like simplicity is one of the goals of like Moloch DAO, just to be similar. So one of the things we can look at as anything that can be like any redundant lines or anything that could be simpler. Is that something that you want us to actually?
Sure. Yeah, take out lines. We have pretty comprehensive tests that go through anything. So like if you run the tests and everything checks out, like it's probably fine.